planes actually look like when they're all spread out. Okay, but that's all I would expect you to do. All right, moving on to section 9.2, partial derivatives. So 9.2, partial derivatives. Here, we saw that we had this term with respect to. Okay. So I always abbreviate this WRT. So for example, so with respect to means treat this as a variable, and let's say all else like a constant. Okay. So for example, or more specifically with respect to x means x is going to be treated as a variable. So treat x as variable. Treat y as constant. And then of course we're going to differentiate. And then with respect to y, again means treat y as variable and x as our constant. Okay. And then we saw that we could do some higher order things. So I guess a quick example of this would be if I had some function f of x comma y. Notice this notation clues us into the fact that we're in 9.2. I have f of x comma y. Let's say that I have this equals x cubed y plus 3x y squared plus y to the 5th, or something like that, plus 13. Why not? Here, the derivative with respect to x is just going to be 3x squared y plus 3y squared plus 0 plus 0. Okay, again, notice, I took the derivative of this guy, 3x squared. Y is just a constant, so it's just along for the ride. The derivative of 3x, that x goes away, it goes down to 1, so I just have 3 times y squared. That y squared, again, is just left over from up here. And since both of these are constants, their derivatives are 0. Similarly, f sub y is going to be x cubed plus 6xy plus 5y to the 4th, and again, plus 0 for this 13. Okay, we saw that we could do this with higher order partials, or second order partials is really what we care about. Second order partials. And my favorite way to do this was with the tree. We had our f. Down to the left, we have this. This was always with respect to x. So you got f sub x. Here was always with respect to y. I got f sub y. And then down here I got f sub xx. Again, this was with respect to x. I got f sub x y. F sub y x. This was with respect to x. F sub y y. So these were all of my second order partial derivatives. And we know that these two are equal in the middle. So it was kind of a good way to check if we had done things correctly. Was if these two weren't equal, we know that we had done something wrong. Okay. So yeah, I will let you guys look at the exam 3 review solutions for an example of this specific problem type, because you'll see in a second that I have to do one of these for exam 3 as well. All right. we have 9.3 was our last section that we talked about on Tuesday, or on Thursday of last week rather. So this was maxes and mins in 3 dimensions. So here we have a process. Step 1, we're going to find our critical points. The way that we do that is we, first off, so I guess let's actually do this slightly differently. We're going to find so for 9.3, these maxes and mins. Step 1, we're going to find all of our partial derivatives. I want to go up to the second order to be clear. Step 2, I'm going to find my critical points. I did this slightly differently in the notes that are posted, hopefully momentarily, online. So find our critical points. We're going to set f sub x equal to 0 and f sub y equal to 0. And then we're going to solve the system of equations that we get. To find some points. A comma B. Okay. Now, step 3, we are going to make a chart where I have my points, A comma B, and then I'm going to just plug them in, fxx, fxy, fyy, and then we had our discriminant, d, which equals fxx, fyy, minus fxy squared. So this is an equation. And then here what I mean is we're going to plug in our point, and then we're going to take all of these values on the left and plug them into our discriminant over here. Okay? And we said that making a chart like this was a really nice way to keep track of our points, especially when we have multiple points going on. And then step 4, we're going to classify our critical points. Okay, so classifying our critical points, let's get another chart going. I love charts, you know. So if I have d greater than 0 and fxx greater than 0, these are the same, which makes me happy, so I have a min. If d is greater than 0 and fxx is less than 0, differences make me sad. So they have a max. And then if I have d less than 0, I don't care about fxx, I have a saddle point. And then if d equals 0, then we don't know. It's inconclusive. All right, so that was how we would classify those things. Again, I wrote up those steps a little bit differently in the review that I've posted, but let's go through and do an example of this, because I think that an example is pretty helpful. So I had written step 3 in a couple of steps, or the problems for 9.3 I wrote in a couple of steps. I'm just going to do them all in one fell swoop. Okay, let me look to see which one of these would be a good problem. So problem number 2 I've noted in the solutions is easier than the one on the exam. So let's do problem number 1. For, again, all of these are coming from the exam 3 review worksheet. So I have f of x comma y equals x squared plus 4y squared minus 2 x squared y plus 4. Okay, so the first thing I want to do is I want to find all of my partial derivatives. Let me know what my margins are so I can kind of try to center myself. So there's my function f. I'm not going to rewrite it. F sub x is going to be 2x minus 4xy, and f sub y is going to be 8y minus 2x squared. Again, this is 4xy. While I'm at it taking some partial derivatives, I'll find fxx equals 2 minus 4y, fxy equals negative 4x, which is again equal to fyx, and fyy is going to equal 8. Okay, so I found all of my partial derivatives. Hooray. Now I want to find the critical points. So part 2. We're going to find our critical points. What I mean to say is we're going to set 2x minus 4xy equal to 0 and 8y minus 2x squared equal to 0 and solve. Now, there's not necessarily an easy way to do all of this, but we know that both of these guys need to equal 0. Okay, all right, so I'm going to solve this equation for y. I think that will be the most straightforward. So y is equal to 1/4 x squared. I can plug that in over here using substitution. So substitution, again, so we talked about you could use substitution or elimination. Elimination doesn't really work when you have higher order of things. So I'm going to say use this, not elimination. If on the exam you're able to use elimination, go for it. You definitely won't get points off as long as you're doing things correctly, but substitution is going to work every time, especially when you have terms that are squared. Okay, all right, so here I'm going to plug in 1/4 x. So I'm looking at 2x minus 4 times x times 1/4 x squared equals 0, or in other words, 2x minus 4 and 1/4 cancel out, so 2x minus x cubed equals 0. I'm going to solve this guy out, so I have x times 2 minus x squared equals 0, which tells me that x equals 0, positive square root of 2, or negative square root of 2. Again, you can do this in a couple more steps than I've done it. Now I want to find out what this means about my variable y. So I know that y equals 1/4 x squared. So if x equals 0, y equals 0. If x equals positive root 2, y should equal 1/4 times root 2 squared, or 1/2. And if x equals negative root 2, again, y will equal 1/2. So I end up with 3 critical points. I have 0, 0, root 2, 1/2, and negative root 2, 1/2. Again, a case like this where you have a lot of critical points happening, it's really nice to use a chart. I did use a chart, cool. I did the chart a little bit differently in my solutions than I will do it now. So let me make a chart, but I need a new sheet of paper real quick. All right. So I'm gonna make my chart here. I'm gonna make it nice and big. I'm gonna know where it stops, here-ish. Okay. So I want these to be my points. I'm gonna recall that f(x(x) equals 2 minus 4y. Fyy is equal to 8. I'll do fxy. It doesn't really make a difference. Then my discriminant is equal to fxx fyy minus fxy squared. Okay, so for my points, I've got 0, 0, root 2, 1/2, negative root 2, 1/2, so for 0, 0, fxx equals 2. Again, I get 2 minus 4 times 0, which is 2. For this guy, I get 2 minus 4 times 1/2, which is 0. Likewise for this guy, 2 minus 4 times 0. Here for fxy, I get negative 4 times 0 is 0. Here I get negative 4 root 2. And here I get positive 4 root 2. Some negatives cancel out. For fyy is just 8, so that will be 8 all the way down. Now for my discriminant, I'm going to be looking at, here I've got fxx minus, or fxx fyy, so 2 times 0, or 2 times 8 minus 0 squared, which is 16. Here I'm looking at 0 times 8 minus negative 4 root 2 squared, which is negative 16 times 2 is 32. And here I get, again, 0 times 8 minus 4 root 2 squared, which is negative 32. Now notice, this guy, I did plug in negative 4 root 2, but that squared undoes the negative inside. Okay, all right. So now let me classify my points. Using our chart. So we know that for 0, 0, our D is positive, fxx is positive. So then I have A, the same makes me positive, and the same makes me happy. So then I have a relative min at root 2, 1/2. I have D is less than 0, so then I know that I have a saddle point, and at negative root 2, 1/2, I have another D is greater than, or D is less than 0, so I have another saddle point. Okay, that's all. All right, so one last thing that I want to talk about on this video, in my remaining few minutes. Materials that you have to study by. You have all of the old quizzes. I'll upload all of my lecture recordings today. This is just audio, they aren't video. I have all of my lecture notes posted. These old quizzes, by the way, are great. I have the keys posted as well. Hopefully you guys have been using the old quizzes all along to help you guys study, because I do write those questions. We also have our web work. Again, do section 9.3. It's going to be on your exam. Okay. We have the exam 3 review, and there are solutions for that as well. So please go through, try the review on your own, and then go through and look at my solutions. I have everything written up the way that I would expect to see it, with as much information as I would like shown. Okay. If you have any questions, again, so we have office hours At this point, we plan to have office hours tomorrow from 10 to noon. If something happens for whatever reason, again, I'll let you guys know about that. Come in, ask me questions, or you can send me an email. And I'm happy to work through problems with you guys that way. All right, with that said, good luck. I will see you guys all on Thursday.